trouble.
Oh,
A recording is in progress.
okay. Thank you. I should have checked with you first, Bill, but since that's what we did last year, I made an assumption that it would be all right.
Yep.
And then it slipped my mind. So please
We're good.
get us started tonight.
Okay. Well, I appreciate you all giving me some of your Thursday night so we can talk a little bit about science. And I suspect that I'm one of the few scientists on the call, although I know Dennis is a well-respected botanist and all. And let me point out one other thing about
Also a scientist.
Mr. Bradbury. I mentioned that I'm a climate reality leader, and Bill was actually in the first class that Al Gore trained for climate leaders. So he has been a pioneer and carried that torch very, very effectively for the last few years. Well, what I'd like to do is, if I can get this started. Yep, there we go. Wanted to talk about climate change. That's my passion right now, and talk about what is it, what causes it, what are the consequences, and then, of course, what can we do about it? Now, the simple explanation of what climate change is, it's caused by global warming. And so because of that, I'm going to focus on what's causing the global warming. And we know that greenhouse gases, we'll talk about those, but they trap heat. The atmosphere warms up, the ocean warms up, air circulation patterns change. We see that severe storms become more common, rainfall changes, heat domes, wavy polar vortices, fires, just a whole, I mean, you're familiar with what the effects are with climate change. And that's why I wanted to dig a little bit more into what's happening, because when you know what's happening, what's causing it, then when you look at what are the factors or what are the actions that we can take to take care of it, that makes more sense. Otherwise, it's just a whole bunch of things. So we typically talk about the main greenhouse gases. The one of them very common is carbon dioxide, but there's also methane, which is just natural gas for the most part. There's nitrous oxide, which is laughing gas, or it's something sometimes dentists use to help with the dentistry. And then there's the fluorinated gases. Those are basically gases that are used in refrigerators or freezers and such. So you can see that 80% of the greenhouse gas effect is coming from carbon dioxide, with the others in smaller amounts. Now, it's interesting to note over on the side below that list of the carbon dioxide, methane, nitrous oxide, and fluorinated gases, it says expressed in CO2 equivalents. Now, what that means is that because these different gases have different effects or different abilities to trap heat, they contribute in a different way than the total concentrations are. Now, let me show you this table, which shows for carbon dioxide, it sticks around on the order of decades to a century or so. Now, its concentration in air, we'll just take it for sort of an average at this point, it's about 415 parts per million. So in a million parts of air, there'd be 415 molecules of carbon dioxide. Now, because that's so common and everything, we'll use that and say a global warming potential of 1. Now, what that means, well, let's jump down to methane. Methane, natural gas, it breaks down much more quickly than carbon dioxide gets out of the system. So it's on the order of a decade or so. It's in a concentration of 1900 parts per billion. Well, to try to compare those two, parts per million to parts per billion, you just lop off the last 3 points. And so 415 parts per million for carbon dioxide as compared to 1.9 parts per million, same as 1900 parts per billion. So it's 1.9 parts per million of methane, so much, much less. But look over to the side. It has a global warming potential of 84. What that means is that if for every molecule of methane, it holds as much heat in the atmosphere as 84 molecules of carbon dioxide. So that means that if we can control methane releases, we are going to be able to have a more immediate reaction or effect than controlling carbon dioxide. Well, there's so much carbon dioxide, we still need to do that. Now, it shows global warming potential over 20 years versus 100 years. Because methane breaks down, you can see that over time, there's less and less there. So an emission right now of a molecule of methane, over the next 20 years, it'll be 84 times more effective at trapping heat. But after 100 years, because some of it breaks down, it's only 28. So when we look at things, we know that taking care of methane now can have a big impact, much more than over a longer period of time. Now, same thing with nitrous oxide. It's in lower concentrations. It lasts longer though. So you'll see its global warming potential is 264, 265. One molecule of that is worth 265 molecules of carbon dioxide. So taking care of that is also a good thing. Now, the fluorocarbons, the refrigerants, stay around for about a half a century, but they have a global warming potential that is hugely more than carbon dioxide. But it's a whole family of gases, so it's not really fair to say one particular fluorocarbon, but because it's something that if we can control where they're coming from or where they're going to, and that's mainly from leaks, that's going to give us much more bang for our buck. So let's start looking at carbon dioxide. And one of the things about trying to figure out what can we do is we want to know where does the carbon dioxide get released into the atmosphere. We see that about a third is from transportation, about another third from electricity, industry, residential, commercial. All of it really comes down to about 98% of the carbon dioxide is from combustion of fossil fuels. That's why trying to cut down on the amount of fossil fuel combustion is critically important. That's why there's so much emphasis on it. A lot of it comes from electricity production, and that would be either from coal or from natural gas in particular. Other uses, such as heating and lighting buildings, is also producing the carbon dioxide. There are some industrial processes like cement production and steel production, just as the effort of making them, the chemical reactions release carbon dioxide, but they also take a tremendous amount of heat and electricity to get that to produce the cement and steel. So you've got a double whammy for those. So we know that those are where it comes from. And so that's where we focus our efforts at taking care of carbon dioxide emissions. Methane, I mentioned, AKA natural gas. That's coming from a variety of sources, oil and gas, and mainly that's from leaks from pipelines and wells. And when there's too much natural gas for their systems, they will flare it, they'll burn it, but it won't be burned completely. So there are high emissions there. When you do coal mining, there's methane that's associated with that, and that gets vented out. There's a big contribution to methane from agriculture. Now, you will no doubt have heard about ruminants that will chew their cud and they burp, and most of the methane is from their burping. There is methane coming from cow flatulence, as in any of the rest of us mammals, but it's not the big thing. So it's really controlling the cow burping. Landfills, decomposing garbage, wetlands, decomposing vegetation, melting permafrost. Permafrost is basically frozen ground that typically holds a lot of organic material. And as that thaws, that organic material starts to decompose, or methane that was frozen in the ground gets released. So in either case, melting permafrost can lead to a release of a lot of methane. So we have nitrous oxide. Where is that coming from? You'll see 75% of it is coming from agricultural soil management. That comes from putting on too much nitrogen fertilizer. It's not uncommon to just overspray nitrogen fertilizer. It sits there and in the sun, and before it gets used up, it just changes from its normal fertilizer, or its fertilizer form, into nitrous oxide and goes into the atmosphere. But you notice there are other things kind of related to agriculture. Grazing animals, the wastes that they are producing as they break down, they can release a nitrous oxide. Industrial production of nitrogen fertilizer. Again, fertilizers are a problem. Wastewater management. We have all those can produce nitrous oxide, and those each require a separate kind of approach to how you're going to manage it. Now, just as a real quick basic review, as you all know, solar radiation comes in and it heats our planet, goes through the atmosphere, and fortunately, it warms us up, which is a good thing. Also, fortunately, some of the radiation that's radiated back in the form of infrared waves that is trying to keep us in balance, it's caught by the greenhouse gases, which reflect it back down and keep us warm. As we'll see in a bit, a long time ago, there was an individual that said, based on his review of physics, the amount of heat that the Earth has should, if it weren't for the atmosphere, should be about 0 degrees centigrade. Excuse me, 0 degrees Fahrenheit, which would be because of the Earth's atmosphere, we have a habitable planet. It's about 59 degrees Fahrenheit on average. So it's a good thing we have it. But then, as we know, that if we were to add a leather blanket, extra time stuff there, the things get out of balance. And so we end up having the radiation trapped and it warms things up. There's where the global warming comes in. And that then leads into the climate change. Well, one of the interesting things is that some of the paleo botanists are able to trap or to catch the record, do a record that goes way back. In this case, it's 800,000 years, and a lot of that is in the Antarctic ice cores. They've shown that CO2 concentrations have varied a lot over time, over these last 800,000 years. They vary with the temperature, as you'll see in this next part. And when you see the high spots, that's basically what they call an interglacial period. And the low spots are when we have glaciers. What's interesting, if you take a look at what the difference between the low periods, the glacial periods at the concentrations of CO2, say, 180, up to the peaks, which would be kind of like where we were a few decades ago, centuries ago, it's about 300. So a change of about maybe 200. Well, if we go to look at what our concentration is right now, we have added as much as was changed from the glacial to the interglacial period. We put that on top of already an interglacial period. So we are way out of conditions of what we're used to. And even worse than that, if we were to continue going business as usual, the way it has been going 40 more years, we are so far out of normal over the last 800,000 years. It's amazing. What are we going to do about that? Now, here's an interesting example of how things have changed. From the time from 1951 to 1980, the James Hansen and Marco Sato put together a graph of average, cooler than average, and warmer than average temperatures. You might be familiar with sort of the proverbial bell curve. Now you can draw that bell curve on it, and I put an arrow there at three standard deviations. What that means that there's about 0.1% of those temperatures were that far out. Now, if you jump forward in between 1990 and 2000 and record those temperatures, you find that things have shifted way to the right. And if you continue with that from 2010 to 2020, it's gone a long ways to the right. And in fact, if you were to look at it, the extreme temperature went from that 1/10 from when I was born to 22%. So just the recording, it shows that it's changed radically over time. You probably have seen this graph before of 0. The anomaly, the change from that average continues to go up. And 2021 turns out not to have been, again, the hottest, but 2021 also was when we had a La Nina event, as compared, you've probably heard of the El Nino event. That El Nino tends to be associated with high ocean temperatures. So by La Nina, it sort of cooled things down. Were it not for it being La Nina, it probably would have been tide or above. So we'll see what happens there. And this graphic is kind of interesting, looking at 19 of the hottest, 20 hottest years have happened since 2002. And this is unfortunately a little out of date because it said last 7 years have been the hottest. With 2021, the last 8 have been the hottest. 2021 falls in there between 2017 and 2015. So we continue to break records. The problem is that CO2 has been released faster than since the dinosaurs were around. So we saw on that other graphic, we were way above what had happened in the last 800,000 years. And people say, well, it's changed before. It certainly has, but dinosaurs didn't care about their cell reception. We didn't have to worry about flooded cities and things. So it's a big deal. So CO2 is a main focus. The effect of methane has also changed over time. You can see sort of ups and downs again from Antarctic ice cores. But since the very recent time, it's gone from a historic average of 400 to 700 parts per billion to the now 100 or 1800 parts per billion. And again, that same sort of precipitous rise. Now, what's the big deal on this? It's important because if you look at for every centigrade change, 1 centigrade change of temperature at the equator, it ends up being 2 to 3 times more heat that ends up being captured at the poles. Now, the big deal about this is that there is normally a big difference between the equator and the poles, and it produces the picture on the left, the stable polar vortex. That's held by a polar jet stream. Well, there are times when that would get kind of wavy in the past, but on the right, you see how with more heat up at the poles, both on the North Pole and South Pole, more heat, that polar jet stream gets wavy and it doesn't hold it in as tightly. And so those polar vortices will start moving around. It's my understanding, I think that Texas is in for another very cold spell. I thought I had just heard. And so we now have, there's, the weather people talk about the polar vortex, and it's real, and this is why. So we know that in the atmosphere, you get the hotter summer temperature, maximum temperatures, fewer winter cold temperatures, minimum cold temperatures, more evaporation, melting of glaciers, intense storms, changes in biological systems, and more droughts. These are all things that we have seen. Now, I'm a marine biologist, so I have a particular interest in the ocean and recognizing that the ocean covers 71% of the Earth's surface. And it's very good that we've got this ocean here because 93% of the extra heat has been trapped in the ocean. The suggestion was if it weren't for that heat going into the ocean, remember I said the temperature was on the order of 59 degrees? The expectation is without the ocean there, the temperature on the planet would be 120 degrees. So 120 degrees is uninhabitable. So the ocean's done a lot. Now, of course, with global warming in the oceans, it heats up the ocean. It also gets heat from the atmosphere. It cools the atmosphere. Again, that's a good thing. You have floating ice that reflects a lot of the solar incident radiation, but that then if the ice starts to melt, the floating ice, then you have ice-free oceans exposed, and that water will absorb that heat. And that's what they call a feed-forward mechanism or positive mechanism. As the water heats up more, it melts more ice, which exposes more water, which gets more heat coming in. So there's one of those aspects is of a potential tipping point. If at some point it gets to the point where it's not going to get full ice anymore. So the other aspect about a warmer ocean is that it causes sea level rise. Warm water expands. About half of the sea level rise comes from a warmer ocean. The other aspect is that it holds less oxygen, so you have hypoxia. We actually have a situation off the coast here in Oregon that results in anoxic conditions and dead zones, which is really bad. It'll kill all the crabs that can't walk away. Another aspect of the freshwater from ice melting is that freshwater is lighter than saltwater. And so it'll sit on the surface. Well, if there's too much ice or melted ice, freshwater on the surface, that keeps the winds from stirring up the soil, the water and mixing things out. That means that it can have an effect on major ocean currents. The Gulf Stream that goes along the east coast of the US carries heat from the tropics up to the poles, which is very good as far as moving things around. The suggestion is that that current is slowing down, which would mean there would be less heat going up to the northern parts of North America and to Europe, which would have devastating effects. So we see that the temperatures keep going up even more more regularly than you saw with the atmosphere. And the record for 2021, we'll adjust this, and that's even higher than what. The other thing, it's not just the surface, as is in the light blue. It's all the way down to the lowest levels. Surface is getting most of it right now. Bothersome part is that 50% of the heat has occurred in the last 20 years. So there's a real emphasis to take care of cutting down the heat, because unfortunately, all that heat's there has, no pun intended, but it's baked in changes to our climate, to the ocean. The expectation is that as a marine biologist, as having spent a lot of time in the tropics, warm water coral reefs are basically going to not be existent after the middle of the century. I won't be able to take my grandkids diving in places that I've seen before. Now, a little bit of history. How long have we known about this? Some people say, is this since Al Gore did his Inconvenient Truth film? And actually in 1826, Fourier was the first person to say that the atmosphere was holding this heat in. He was the one, remember I said that if it weren't for that greenhouse gas, the temperature would be on the order of 0 degrees Fahrenheit. And so he had advanced this about, in 1856, Eunice Foote was doing some experiments, which were very unusual for a woman to do experiments in a man's world at that point. But she found that, in fact, carbon dioxide trapped heat. So since 1856, we've known what carbon dioxide could do. And then another 40 years later, Arrhenius had proposed several different things. He called it was greenhouse gas effect. And it was basically, he was the one, at that point, he said that looking at the physics, the Earth's surface temperature should be 50 degrees. More importantly, what he said is that if the concentrations of carbon dioxide doubled, that would cause the Earth temperature to go up by 9 degrees Fahrenheit or 5 degrees centigrade, which is pretty interesting because in 1896, he said what we're seeing happening right now. So we've known this stuff for a long time. In 1938, Guy Callender said that he calculated it and said that the previous 50 years of warming was due to carbon dioxide in the atmosphere. Now, the final one here is Dave Keeling, and he's got a curve now named after him, the Keeling curve. He was a scientist, air chemist that was working in Hawaii and started measuring the concentrations of carbon dioxide in the atmosphere. It's continuing to this day, this incredibly long record. But as you can see in the graph behind him, that's the record of carbon dioxide in the atmosphere. And it continues to go up unabated. So we've known about this for a long time. In fact, you probably heard about Exxon. The Exxon knew about it. When did they know? In 1982, their Exxon scientists, the Exxon hired some of the best atmospheric scientists to say, what is this stuff all about? They published this report, which at some point was released because it was only for internal discussions, that basically documented exactly what we see now. So it's been known for a long time. And that's why it's very frustrating to those of us that are trying to get the word out right, that Exxon and many of the other oil companies and their societies, American Petroleum Institute, and many others have said, oh, it doesn't exist, when their own scientists demonstrated that, in fact, it does exist and it is important. Let me touch real quickly on some of the models. They are very complicated. There's a lot to it, but it's, in the simplest terms, it's what comes to the Earth and what goes back out from the Earth. Ideally, in a stable climate, they would balance. Well, there are some things that are going to change, the solar radiation that comes and goes, various other processes, but you'll see that there's a lot of these little parts in there that when the models are run, as they get better and better computers, faster and faster, more powerful computers, they add more detail to it. The interesting thing is the fundamentals really haven't changed. The predictions really haven't changed. It's been more precise. So looking at what goes into the models, they look at those greenhouse gases. Notice that it says water vapor there. Water vapor is actually a very potent greenhouse gas. Anybody that's been in the desert overnight knows that if it's a clear sky, that desert drops in temperature fast, or it warms up fast in the sun. If it's cloudy, then it doesn't change near as much. Difference between water vapor and the other greenhouse gases is it changes on the matter of hours or days. So it's not easily factored into these models. However, it is in clouds, and clouds have an effect too. Now, it's true that solar radiation changes over time. The sun's output changes and changes in the Earth's orbit. In fact, the interesting thing about it is if you were to look at just the change in the solar output from the sun, we should be in a cooling period. People have said, all right, how much is the human contribution to global warming? And the answer is over 100%, because we should be cooling instead of heating. So I mentioned volcanoes, clouds, ice sheets, land use changes, all those have to be factored into the models. But it'd be pretty complicated. Now, in order to get a sense of what's being projected as opposed to predicted, we project it based on what we think would happen under certain conditions. Now, the latest Intergovernmental Panel on Climate Change, the IPCC report that was released just late last year, used what they called shared socioeconomic pathways, SSPs. Don't really have to think about that other than the low one, SSP 1 to 1.9, which related to how much the emissions were and how much heat was trapped. We go from very low to intermediate, high, and very high. I will say it right about now we're on track at the intermediate greenhouse gas emissions. So it's not the high or very high, although that could change on a variety of things. So if we look at their, from the IPCC report, the one that just came out, and project it forward from 2015 to 2050 to 2100, you can see that the SSP 1 to 1.9 shows a maximum temperature of about 1.4. You might remember that the Paris Climate Accord was trying to keep it below 2, at well below 2, and typically 1.5. So that's really what we're looking at. In Fahrenheit, that's 2.5 degrees Fahrenheit. Now, that's the very, very low. The one that's 1.8 is where it's low greenhouse gas emissions. 2.7 is a moderate amount of greenhouse gas reduction. So unfortunately, as I said, we're on that middle sort of orange trajectory. And notice that for the lowest and the next lowest, the SSP 1 to 1.26, those actually start trending back down, whereas the other three are continuing to go up. This only goes through 2100. So we see the projections are, well, we're in charge. We know we're the ones that are causing it, and we know what we have to do. Now, what's about the reliability of these models? Unfortunately, they are underestimates. And they continually reviewed, critiqued, and checked In fact, this is the 6th cycle of these models. And that when I say they tend to be conservative, you see that the graph on the right, where it's the tide change, or the, sea level rise. And you can see that on the left, what's been measured and continues as it's been measured, both from tide gauges and the satellite, that's at the high end of the projections. And so unfortunately, we have been under predicting things. So when we say, oh, it would only be 1.5 or only be 1.9, the projections so far have been underestimates. And how about a consensus of this? This, if you can see the details on the green circles, these were a compilation of assessments of individual authors to say, how certain are you that it's humans that are having the effect? And it varies from as low as 93 to 100%. And basically the people that have the most direct information on this, the scientists, the climate scientists, the more training they have, the more consensus it is. You're not going to have 100% because you never seem to have 100% agreement on all these things. So basically, that's, I hope, enough of sort of the science without too much of the details. So you get a sense of why is global warming happening, and why is it that we want to focus in on certain things, whether it's cutting down on greenhouse gas, carbon dioxide emissions from burning fossil fuels, whether it's in a power plant or in cars, or looking at getting rid of excess fertilizer or other things. So at this point, it's, well, what actions can we take? What are we important to do? And there are basically 2 ends of the spectrum. And I say it's a spectrum because it goes from personal, one-on-one, to collective, one-on-many. So we have to have, you can talk about political actions where you can vote. And that's why when Alice asked if I would be willing to talk, I'm most happy to talk to you guys, because that's in your charter. It's voting. And so you can either, and you should certainly be voting, but then you can also take it, you add your voice to others, and you talk to your elected representatives, follow the necessary policies, do things like that collectively. On the personal side, on the financial things, you can save money by turning off lights. You can do other things that will be helpful there. You can change your investments. You can do, as I'm trying to convince some of my fellow alumni to advocate for a divestment of the endowment from fossil fuels. And in some places it's working, in other places it's a little bit slower. On the educational side, one of the things is to do what you're doing exactly right now. Get educated, understand what's going on, ask questions. Find out the resources, which I'll talk about in a second, that'll allow you to do to be properly informed. And then the other half is to talk to other people, work with other people so that you can get the information out. Now, when we were putting together Coastal SoCan cards, we had business cards. They're actually a double fold. And on the outside, it was our names and a logo. On the inside were 5 different areas that you can take individual actions. The individual actions were for things like food or water, energy, transportation, recycling. If you would like some of our cards, Alice, I can send you some if anybody would like them. I know that I think some of you already have them, which is good. The things vary, and one of the things that I like most about this, I've been called frugal. I've actually been called a lot of things different from that, but I like frugal. And most of these save you money. You know, when you turn off unused lights, you use a power strip for TVs, you let your lawn go dormant, or you make a food forest, you fix leaky faucets, keep your tires, all those save money. So who's not to like that? So those are individual actions. The suggestion, though, is that if we all did all these individual actions, we probably still will only get about halfway to the area to where we need in reducing climate change. So that means we have to do that collective action. So what are the most important? Getting engaged, involved, doing exactly what you're doing. Becoming informed, joining others, writing letters, vote for responsible action on climate change. And again, why I love coming and talking to you. And talk to everybody you can. There's some very uncomfortable conversations, but doing it right can be important. One of the best ways is find common ground. I gave a talk to the Southern Oregon Fishermen's Association, and I was told, don't say climate change, don't say global warming. I didn't. I talked about changes with the fishing, talked about how crabs are being affected, talked about things that we all actually cared about, and explain how it affects you. And if possible, if you can relate to it, how it affects them or get them to talk about it. So basically, you're getting away from the buzzwords that are so politically charged now, it's beyond frustrating. But it's a matter of talk to people. Now, there are resources you can get. There are periodicals. There are periodicals like the Yale Climate Connections or Inside Climate News or Skeptical Science. Each has a different bent, but it is very, very focused at climate change. Others, like National Academy of Sciences in general, has climate focus. There are periodicals like The Economist or the New York Times or many others that have specific focuses on climate posts. There are resources, books that you probably be hard pressed to want to read, even want to read, the IPCC 6 assessment report, recognizing that 4,000 page book is only the first of 4 volumes. This one talks about what's the drivers, the physical basis, what we've just been talking about. Another one that's been around for about 4 years is called Drawdown. Now that's interesting because Drawdown is about 100 different actions that we can take right now with existing technologies. Actually, it's 80 of the technologies that are here now and another 20 that are on the cusp and maybe would be helpful. And so those are things that it's a compilation of those that would be very helpful to implement. Now, the fellow that edited that, Paul Hawken, has just written a book that was published in the last 2 months, and it's Regeneration, Ending the Climate Crisis in One Generation. The interesting thing about that is he talks about a book, and yet at the end, he talks about action. What can we do? One of the things is make a punch list, figure out what you want to do, and then stick to it. Talk to your spouse, talk to your friends, family, neighbors, and try to sort of cooperatively work towards that. Another book that's interesting is The New Climate War by Michael Mann. That was in the middle of last fall. Michael Moore has been at the front of much of the climate battle for quite a long time. And his focus was more on the deniers. Well, his emphasis is that the deniers can't deny it anymore. It is real. Now it's a delayer. Now they are saying, well, let's study it some more. Well, we have to do this. And in fact, it is kind of greenwashing. It's not really like having things happen. It's a matter of putting it off. And they get their way. They don't have to deny it. They just don't have any progress on it. The last one there, Saving Us by Catherine Hayhoe, is an interesting one. And it ties back to what I was saying of talking to people. Catherine is a well-respected atmospheric scientist and a climate researcher. She's also self-described evangelical Christian. She has, by her own admission, she has talked to thousands of people, many of whom are very deeply religious, and she's found common ground. It's a matter of talking to people, things that matter. So beyond books, there are government agencies, NOAA, National Oceanic and Atmospheric Administration, NASA, National Aeronautics and Space Administration, EP, the National Academy of Sciences, Engineering, and Medicine. All of those, especially NOAA, EPA, and NASA, have amazing resources for people to learn about that, for kids to learn about that. Graphics are fantastic. The National Academy of Sciences continues to put on programs. There was one just today that was talking about using the ocean to battle climate change. Others, climate advocacy groups such as 350.org, the Climate Reality Project, of which Bill and I are members, the Climate Citizens Lobby. Each of these have specific, more focused one way or another. All of them are very strongly being active in trying to affect the changes we need. On a local basis, as you mentioned, I'm part of SOCAN, and we are trying to take action very focused in Oregon. Other environmental groups that are broader, but they also have a very strong focus on climate is Union of Concerned Scientists, Environmental Defense Fund, the Natural Resources Defense Council, the League of Conservation Voters. Most of these, pretty much everybody has local chapters. So there are a lot of resources that you can get involved in, you can use. So kind of in closing, what can we do? And again, this is why I like talking to you guys. Vote, help people get out and vote, help people get educated to get vote, run for office and win. Be out there in Brookings to try to make changes, and the wins against which he has had to run are challenging, but we keep trying, which is the best thing. Talk with friends and family, make lifestyle changes, like having a smaller car, getting an electric car. Join activist groups, write letters of the editor, guest editorials, and write your elected representatives. From what I've been told, and Bill, you might be willing to add to this, somewhere between a letter is worth between 100 and 1,000 votes. So that if you write a letter, they consider that many, many, many more than just one person that has written the letter that's going to be concerned. So with that, I will close and take questions if anybody has any. I'll stop sharing my screen. So.
Okay, well, I would just, I know you just invited Bill Bradbury to make a point, and if you have one, Bill, I'd like to hear it, because you're also a certified environmental speaker, climate change speaker. I thought Bill's presentation was wonderful, but please chime in.
Well, I very much enjoyed Bill's presentation, and I used to, before we got all this COVID restrictions, I used to travel all over the state giving climate presentations about. As I was doing that, I was using my, I was driving a Prius, which is a good high mileage car, but it's still burning fossil fuels. So I finally, about 6 months ago, purchased a Tesla, and now I can't travel because there's no groups to go visit with anymore. But at least I don't feel guilty when I'm driving to the store, because Tesla is obviously a 100% electric car. And what's nice about that is that living in the Northwest, basically connected to the Bonneville Power Administration's electric system, most of, not all of, but most of the Bonneville Power Administration's electricity comes from hydro, which has other impacts on fish, but doesn't produce greenhouse gases. So I can feel good about charging my electric car from hydro and not contribute to global warming, either by driving my car or by charging my car. So I'm enjoying that. So,
and that's where the collective action.
And you're impressing my.
Sorry,
yeah.
yes.
I was just going to make a snarky comment how it would impress my 13-year-old granddaughter who notices every Tesla she sees on the road. So, Carol, did you have a question or a comment?
Yes. Bill, are you involved in the offshore windmill stuff that they want to put on the South Shore here, or?
Well, I will, because whether you were talking to Bill Bradbury or me, yes
Oh,
is the
you.
answer for both. Yeah, Bill is the president of Ocean, Oregon Coast Energy Alliance Network, and I am the environmental chair for that. We're both on the board. And I think, Bill, why don't you explain the community base that Ocean is?
Well, I think the thing that's most interesting about Ocean is that it's a very many different interests have come together to be part of Ocean. You've got you got the electrical workers. You've got so you got a union that's very supportive of it, of fully investigating ocean wind. And then you've got folks like Bill Gorham, who, like he said, he's the chair of the environmental committee. You also have the folks that work at Sauce Brothers, which is the ocean tugboat company, and you have and several other. I mean, there's a whole bunch of people involved that are all from the South Coast. And I think that's what really makes it unique, is that it is all South Coast, but it represents many, many different interests that have come together and said, we really need to look at and investigate the impacts of ocean wind, because it's real clear, like Bill just showed, that we're producing way too many fossil fuels, are burning way too many fossil fuels, and we've got to find alternative energy sources. And ocean wind off of southern Oregon and Northern California, the wind resource there is called the Saudi Arabia of wind. It's a very steady wind about, what is it, about 30 miles offshore.
Yep.
That's just a very steady source of wind energy that really we could definitely benefit from tapping. So back to you, Bill.
One of the nice things about it, as Bill was saying, it's a diversity of people. The vice president is a surfer and a fisherman. And so you're probably well aware of the Jordan Cove project. There are many people that were supporting it. There are many people that were against it. Many of the people on both sides are part of Ocean. And as Bill mentioned, we want to see what the impacts are. We want to make sure it's done responsibly, make sure that the benefits are very strongly outweighing any impacts, but it's find out what those impacts are. And so trying to do the studies, advocate for incorporating as much input from people, answering their questions, get information out there is critically important. So rather than saying we are supporting the developers to come in and do whatever they want, it's not that. We want to make sure that there are benefits locally. Now, Shannon Souza, who's the executive director, is really good at far better than I think either Bill or I in talking about the combined benefits. Bill mentioned the wind offshore is amazing. It's some of the best in the world.
Right.
And it's the strongest, most consistent, most reliable, most predictable. It also happens to make it's sort of complementary to onshore wind and even more so solar. And so it can very easily that gap of when wind's not blowing and sun's not shining, things like that. And so trying to make sure that as much of the information that is necessary to make intelligent decisions is out there and get input from people like you and anybody else on the call.
Thank you.
Yeah,
Pauline,
you're muted, Colleen.
you're muted.
I'm a little curious when you were talking about agriculture and you said that excessive nitrogen application is one of the high things. Why
Yes.
would that be? Because as a farmer, you wouldn't want to spend extra money putting excess nitrogen on your fields. So why is that happening?
You're correct in that what you wouldn't want to, but it does happen. There was a recent story and they called it, I want to say the wheat belt for Mexico. And basically the farmers would put the fertilizers out there, and if the rain didn't come at the right time and they would put on excess, and just sitting in the sunlight, it changes to nitrous oxide. And so it breaks down into the wrong products. You'd think that they would only put on the right amount, but that requires a lot more sophisticated understanding of what's needed. I know Dennis is a certified master gardener, probably would have a better explanation on the biological side of it, but the simple reality is that's what people do.
So we're talking, well, like my brothers, I mean, they hire a expert chemical guy to come out and look at their fields and, you know, determine how much exactly is needed. So we're talking people who do not have that type of a resource, who are still just kind of farming the old way, that they know they need that, so you throw it on.
Right. Yeah.
Okay.
Yes.
We, as a master gardener, if someone's plant leaves turn yellow, that's an obvious nitrogen deficiency. So we will tell people sometimes, you know, that's one of the things that you need. But we always recommend getting a soil test first of all to make sure that you don't already have enough and that it's not something else. And then, of course, what they drill into us is the label is the law. If you buy a fertilizer, read it. If you put 4 times as much as it says, that's on you. You're breaking the law. So it's really trying to get people to understand that you really need to read the label and see if it's appropriate, number one, for, you know, for a lawn or for certain plants or whatever, and only use it at the dilution that they say. And then, as you said, Bill, you know, there are different times, or, you know, if it's going to rain, maybe you don't want to do it, or maybe you want to do it. So all of those may come into play also. But nitrogen does have its benefits in the plant world, but excess nitrogen doesn't, because it'll also, you know, can burn the roots of the plant. So yeah, I mean, that's where I'm coming from. So
Yeah. And it's interesting. Go ahead, Bill.
Bill, I would just add, my daughters, they live in Langlois, south of me here in Bandit, but north of you in Brookings.
Mhm.
And both of them are what I would describe as regenerative farmers, in that they don't use any artificial fertilizers, but they sure do grow a lot of crops and feed a lot of people. You know, so there's a lot of different ways to grow things, particularly if you have access to compost and other things that you can use to help your crops without a lot of artificial nitrogen. So that's better for the climate if it's doable.
Carol.
Okay, Carol, a quick question before we wrap up here.
Yes, on that same farming subject, I've read a lot where no-till agriculture is actually a good way to help climate change. And I've even read things where it's a big that would make a huge impact. And is that because the 7% of nitric oxide is, even though it's only 7%, because it's what, you described in that graph, which I kind of sort of understood.
It's more
Makes a
powerful.
bigger impact is what I'm trying to say.
Exactly. Yeah, I actually hosted a screening of the film Kiss the Ground last night for Spokane, coastal Spokane. And if you are on Netflix, you should take a look at it. It's free to Netflix subscribers, and it's Kiss the Ground. And it goes through all of that. It's a very good film. It's narrated by blanking on his name. Who is that?
Woody.
Woody Harrelson, right? But it goes through all that, and it's exactly what Bill is talking about.
Got
The
it.
impacts to the farming and to the environment are tremendous. So I would recommend taking a look at that.
Thank you.
Okay.
Yeah.
Thank you. Any last closing comments, Bill?
No, other than to say that I want to thank all of you for participating. And I, like Bill, I enjoy doing these and getting people excited and educated. And again, having a chance to talk to League of Women Voters is ideal, because it's the stuff that you do, get the people out to vote, that are going to make a difference. So good on you. So thank you very much for the invitation.
Thank you,
Thanks so
Bill.
much, Bill.
Glad to.
Thank you.
Yeah.
Terrific.
All right.
All right.
Good night, everyone.
Good night.
Hey, have a good night. Thank you.